Well, hello and welcome to Into the Terminal. Today we're going to be talking about user accounts and user account uh, password aging and password control. This is going to be another series on our security arc where we look at things that are kind of common across different security compliance policies and try to highlight some of the things you can do in Red Hat Enterprise Linux to make those reality. So we chose this one today because a lot of different security policies require you to have rules around what users' passwords look like and how you control access to your system using different parameters for users. So let's jump on into the terminal. All right. So we have a command for changing the age of passwords. And it's called chage. If you run it without any additional arguments, it'll give you this nice usage diagram. And it's used for changing the password aging settings for user accounts on your machine. And after the transition, we'll talk about where this is stored and how it's represented and a bunch of other stuff. But to get going in our critical path, how about we talk about setting some parameters on one of our users to comply with a password policy? So, for example, maybe we're going to require that users not be able to keep their password for more than 90 days. So I have this user named Jim. And if I do a chage-l on Jim, this is what he currently looks like. And you can see that his password expires never. So we want to change that to 90 days. So we're going to do a chage dash m 90 for Jim. And now when we run the chage-l for Jim, we can see that his password expires 90 days from the filming of this episode, right? So his password was last changed today, and 90 days is going to be June 22nd. But that parameter that we set right here, this 90, will be applied to the point at which he last changed his password. So if he updates his password tomorrow, then his password will expire 90 days from that last password change. All right, another thing that we might want to do. Maybe we should start warning Jim in advance that his password should expire. And so right now, 7 days before June 22nd, when Jim logs in, he's going to be told that his password is going to expire. So if we want to maybe grow that to 2 weeks, right, 14 days, we can do a chage dash capital W to change the warning days of 14 days for Jim. And again, if we look at chage-l, there's the updated value that we provided. But what happens if Jim's password expires on a weekend or on a non-work day? So one of the other things we can do is set this password inactive. That's basically a grace period. So after the password is expired, Jim can still use it to authenticate. However, if he does that, he will immediately be forced into a password change activity. So we could do a chage dash I, right, change the inactive days, and maybe we'll give him a 5-day inactive time. So after that January or June 22nd date that's currently on his account for his password expiration, he will have until June 27th before the password is completely unusable. If he logs in between June 22nd and June 27th, he will be permitted to authenticate with his password, but will immediately be launched into a password change, which will reset his date of last password change, which then resets his password expiration time, and then also sets the password inactive. Right. And again, if we want to see all this, we could chage-l for Jim. And this is what it looks like for Jim and his logging into the machine and controlling access to his password expiration. All right, stay with us after the transition. We'll talk a little bit more about how this is stored, where we can go to find more information about it. And we're also going to dig into password quality. So when Jim changes his password, how do we make sure that it meets the quality guidelines that our security policy also requires, right? Like length, number of special characters, or different types of characters. So we'll be covering that after the transition as well. Stay with us. All right. So today we're talking about managing passwords for users. Now that we've transitioned off of the critical path of skills, we're going to go into a little bit more detail about how this all works. And then we'll also add in the additional parameter of how do we actually control what users can set in their password, right? Controlling things like length, upper and lower characters, digits, specials, things like that. This is also a great time to ask questions in the chat if you are viewing live, or if you're not viewing live, you can always put comments. And both myself and Eric, who is not with us today, do keep up on comments and will respond in kind. All right, let me just take a quick look through here. All right, so I don't see anything yet. So why don't we talk about where all these changes we applied to Jim are stored? So again, let's take a look at Jim with chage-l. Oops, and I have to tell who to show, who to list. So change is for changing the password aging information for a user. And this is all stored in the Etsy shadow file. So you may recall from previous episodes where we've talked about user management, Etsy shadow is where we actually store the user's encrypted password, but it's also where we store this additional meta information about how we treat the user's account. So if we do just a quick look at Etsy Shadow, we can look at Jim's line down here at the bottom, and the file is the user that this is the line for, their encrypted password string, and then right over here, let's try that again, right over there, these additional fields are where we're storing the password aging information. And so that first field is the date of the last password change. So in our change output, it said that his password was last changed on March 24th, 2023. And in this file, it's telling us it's 19,440 days since the Unix epoch, right? Which is January 1st, 1970. So that's the last day that the password is changed. Um, There is no minimum number of days to keep a password before you're allowed to change it again. That's what the zero field means. We changed Jim to be have a password expiration of 90 days. That's the next field. We changed Jim to have a warning days. So in advance of his password expiring, he has 14 days that when he logs in the system, he'll be told about his password being set to expire. We set Jim with a 5-day inactive period, right? So after his password expires, he can still use it to authenticate the machine for 5 additional days. However, when he does that, he will be immediately dropped into a password change dialog that will ask him to set a new password. And then there's two fields stored here that we are not currently using. One is the account expire field. So this is the date on which the account will automatically lock. And the last one, I think, is not used. But you know what? There's a place we can go to look. All this is documented in the man in section 5 for the shadow file. All right. So here it tells us, back. The format of the file, if I can stop sloppily scrolling, the format of the file is login name, encrypted password, date of last password change, minimum password age, maximum password age, uh, warning days, inactive days, right? That's the grace period, account expiration date, and reserve field, that trailing thing at the end of the line not used for anything. All right. So I just happen to know all those fields off the top of my head from, gosh, too long in Unix and Linux. But if you're not able to commit it to memory, you always have the man pages, specifically man section 5 shadow. If you just do a man on shadow, you won't get what you want. It'll pull the first available man page, which is the one in section 3 that talks about the shadow system call and how you use the shadow system call in programming, which is not what you will be interested in finding out. So, man from section 5, which is the configuration file section for shadow. All right. So, what else can we do for Jim here? Maybe we do want to change one other parameter. So this is one I think is often overlooked. The one parameter that we didn't really change in the critical path was the minimum number of days that Jim has to keep a password before he'll be allowed to change it again. So if we just do a chage, we could also look at the man page, or -H would also display this message. So if I do a chage dash lowercase m. All right, so what I did was I set the minimum number of days Jim has to keep a password before he's allowed to change it again. The reason I do this is because if you have a password remembrance set where like users can't reuse the same password for 3 passwords or 5 passwords or whatever it is, you'll get users like my own father, where he would change his password to be in compliance with the password policy. And then he'd immediately change it, change it, change it, change it, and then set it back to what it was originally, thereby not reusing his last 5 passwords because he just sat there and changed it a whole bunch of times and being back on his original password. So setting a minimum number of days means you're forcing them to use this password for this long before you'll permit them to change it to something different. Um, and that'll avoid people just sitting there and cranking through a series of passwords to get back to what it was originally, because that defeats the whole purpose of making them change their password every so often. All right, how this looks in the chage-l is right here, the minimum number of days between password change. And then this is also reflected in the Etsy shadow line for Jim, because that's where this is actually stored. One of the nice things I like about Chage is that it takes those really ugly dates. Like, remember, Jim's password change was like 19,000 something something days since the epic, and it converts it into a human friendly date that I can read. Um, but if you are manipulating dates in there by hand, you would want to make sure that you use the epic dates rather than like a human friendly date, because that's not the format of the data there. All right, the last field in the Etsy shadow file that we didn't mess around with was the expiration field. So setting an expire date on an account means that on this date, the account will automatically be locked. And even though it may have a valid password, it can no longer be used to log into the system. So this is really excellent for people that you know that are on a finite time on working with the system. So, for example, if you had somebody come in for a month as a consultant to help out and do a task, when you're going through and creating their account, you could just go ahead and put a month expiration day on their account, so that when they leave after their month, it's already locked. They can't use it to log back into your systems. And it turns out it's a changeable day, right? So if turns out that contract gets extended for another month, you could go in and adjust it for that person pretty easily. So if we wanted to set a date for Jim where his password will, or his account rather, will automatically lock, chage dash capital E. And then if we looked at the man page for chage, we would see that the date format that it wants is the 4-digit year dash the date, the month, and the day of the month. All right, when we look at chage-l now for Jim, he has a account expire setting. So that'll expire him next Friday. And if we look at the output that it stores in Etsy Shadow, you can see that the change command actually took that formatted human-friendly date and transformed it into a Unix epic-based date. So handles all the date conversions for you, which is pretty nice. All right. You could also use things like the date command to calculate that date for you when you use chage. So if you're doing something like a shell script, when you're adding a user, you could do something like this. All right, so what we're going to do here is we're going to set the expiration date on Jim's account to be today's date plus 90 days, and we're going to output it in the format year dash month dash day. Right, and when we take a look at chage dash L, right, that updated his account expiration to be 90 days from today because we used the embedded date command there to do the calculation for us and output it in the right option uh, to pass to the chage command. All right. So let me take another quick run at the comments to see what's out there. And after we address any questions, then we'll move into password quality. All right. I see some back and forth about our lovely sudo episode the other day where things did not go quite as planned, but we're doing much better today because we actually, tested stuff before we went live. All right. I see Fernando asks if you update Etsy password with VIPW, how do we synchronize with Etsy Shadow? So VIPW is editing the password file, right? Etsy password. The um, content inside of the Etsy Shadow file is stored separately. So VIPW does not change Etsy Shadow. Um, so there is no syncing between the two, right? You'd have to use something like Chage to customize or update the Etsy Shadow file. All right, Fernando then asks if you change things in Etsy password, how does that affect Etsy Shadow? It doesn't. So things that we store in Etsy password are different. Things in Etsy password are things like the person's shell, things like their home directory location, a comment to tell you about the user, right? So it's a different set of metadata about the users. The stuff stored in Etsy Shadow is password aging and account aging information only, in addition to the encrypted password. All right. And personally, I would not do things like edit those files individually because the likelihood that a mistake is made will like mess up a whole bunch of things. So I use tools like Chage to interact with the Etsy Shadow file. I would use a tool like user mod to interact with the Etsy password file because you can set all the parameters in using user mod and not have to worry about maybe accidentally deleting a colon that would break a line in its password and then potentially break um, accessing data all the way across. All right. So I think that covers the rest of our questions. So let's take a minute to talk about password quality. So the other thing that is often the case in security standards is they will ask you to create passwords that are a certain size, right? All users should have at least 8-character passwords. They should be a mix of characters, right? Not just all lowercase. And so the way that we implement that in Red Hat Enterprise Linux is the password quality um, configuration file. So here in Etsy Security, there's a file called pwquality.conf. So this is where we can do things like set how long things are required to be, or if we're going to force a specific type of character that we want. And the default way that we work with this file is essentially we want to be encouraging of people setting good passwords. So this is not how a security auditor would ask you to set it. This is more in guidance with some of the research that we've seen come out of places like the National Institute of Standards and Technology. So it turns out that for auditors, they're going to do things like 8 characters, one uppercase, one digit, one special, right? And so if that's the thing that you want, you could do something like this. So the minimum length is 8, right? 8 characters. The digit credit, I'm requiring, that's what the minus means. I'm requiring one. The uppercase credit, requiring one. And the other credit, right? That's a special character or something that's not a lowercase, uppercase, or digit. I'm requiring one. You could also set a minimum number of classes. That's a little bit further down. That's again more in like the let me suggest how to make good passwords section. So setting these minimum length, that's the number of characters, and then setting the credit that you would grant for different class of characters. This is how you can force people to set a password of a specific complexity or specific mix of characters. And this is probably what an auditor looking at a security policy is going to be looking for. However, is an 8 character password that's really hard to remember a better password than a 20 character long password that's all lowercase characters? So it depends. Also, you could do things like encourage people to not set all lowercase characters. So another way to use this file is to set a score that you're wanting to achieve with a password. So instead of saying the minimum length is a number of characters and how many of each type of character you're going to force them to have, you can instead set your minimum length to something of a specific number, but then give bonus points for that score, for that length score, by using the different characters. So, an alternate way that we could kind of encourage good passwords would be to set a minimum score or minimum length of 25. Now, if we do nothing else, we're going to require that to be 25 characters long. So if you chose to set all lowercase characters, a minimum length of 25 would be 25 characters long because by default, every different type of character is worth 1 point to reach that minimum length score. So if your score is 25, you need 25 characters. However, what we could do is make certain things worth more points. So we could say something like, you know what, if you use a digit, I'm going to give you 3 points towards that 25 point goal for my minimum length of passwords. And if you use an uppercase character, I'm going to give you 3 points towards that 25 point goal that I'm going to hold you responsible for. And if you want to use a percent sign or space character or comma or something other than a digit or uppercase, you'll get 3 points for going towards that minimum length score. And then we're also going to set explicitly what a lowercase is. So if you do all lowercase or a lowercase character, that's going to get you 1 point towards your minimum length score. And so by setting it this way, I will allow you to set a 25 character long, all lowercase password, or you could set a 9 character long, all digit password, or a 9 character long, all uppercase password, or a 9 character long, all other character password. Um, or you can mix and match and get you to a long enough to meet that 25 score minimum. that I've set with that minling requirement. All right, so why would I do it this way instead of something else? So it turns out there's a whole bunch of research that indicates that longer passwords are actually better passwords. They're better because the amount of entropy that they create when doing their encryption is higher. And so if someone was going to try and brute force passwords, if they know that you have 8 characters as a requirement, they could try all permutation and combination of 8 characters, of 8 of any character on the keyboard. But if you allow people to have 25, 30, 50 character passwords, that's a lot more combinations for them to try and brute force that password. Additionally, um, beyond that, uh, you can set it of any upper and lowercase. Turns out that upper and lowercase or other characters don't actually make better passwords in terms of like remembrance or uh, I don't know. It basically is like increasing the combinations of characters that someone has to try when they're doing a brute force. But if they know that the length, that's still a finite number that they have to try. So by not limiting the length and allowing them to be longer or shorter than 25 characters, but still greater than 8, you're making someone actually have a lot of uncertainty in their in their cracking attempts. So anyway, that's another way of approaching password complexity that might lead to happier users because they can not have these crazy combinations of hard to remember character combinations. Um, that might get you a better security posture on the machine as well. All right, let me turn over here and take a look at anything else because I said something probably a little bit defamatory. All right, I see that inittux references Red Hat IDM. That's Red Hat Identity Manager is good for password policies and central user management. Indeed. So what we've shown here is individually setting things on a user account on one machine. But when you get more and more machines, you have to take these policies and you have to take these settings and apply them across more and more user accounts on more and more machines. So having a central place to manage those settings is really handy. And you could do things like use a configuration manager and manage this configuration file as an example and populate it across your population. That would work. Or you can go to a central place where all your user accounts and their credentials are stored. So things like Microsoft Active Directory or Centrify, or what comes with the Red Hat distribution is Red Hat Identity Manager. So it's Kerberos plus LDAP plus DNS settings, and I think also secure socket layer stuff. Comes with the distro. No additional software is required other than installing the IDM server packages from the already existing distribution. All right, and then Nate said, "Yes, we decided that was too deep for this episode, and it is. So we will not be going into depth on IDM here today, but it is an option um, for central securing of passwords and users." Oh, I see. There's a mention about uh, doing it in this way with the minimum length and adding bonuses for different types of characters would turn it more into a game. That's pretty funny. I like that. All right. So it looks like we're out of questions. These are the things that we want to talk about today with Into the Terminal. So join us next week, where hopefully Eric returns after he survives his internet outage. And next week we'll be talking about auditing on the machine. Specifically, we're going to be talking about Audit D, which is setting up logging for different system activities that occur on the machine. But we're also going to be discussing T-log, which is session recording. We've had an episode in the past on T-log, but this is another way that you can meet some of those security policy requirements of having a log of what activity was done on a machine over time. So, thanks so much for joining us today. And don't forget to mash that like and subscribe button. We'll see you next week. Bye, everyone.